Welcome everyone. In the last session we had discussed about structural equation modeling. We had just briefed about structural equation modeling and what is the role of structural equation modeling, right. So, in this case when you talk about structural equation modeling which is nowadays highly used in all kind of researches. Structural equation modeling is built upon basically three kind of statistical techniques, you can say, right. Basically the three are regression, or if I say it is multiple regression, right. So, multiple regression, factor analysis, right, factor analysis, and the third I say is the chi-square, right. The three statistical measures that are highly used in structural equation modeling are these three, right, chi-square. So, the chi-square talks about the goodness of fit, right. So, goodness of fit index. So, it tells about whether the observed and the expected model, the observed model and the expected model, are they more or less same or different, and if they are same then it is a good thing, right. If they are close or same, that is good, but if there is a lot of difference between the observed and the expected, then it is not good. Okay. So, what in the first part we talked about the measurement model, right. So, we said that the entire structural equation modeling can be said as a combination of the measurement model and then the structural model. Okay. So, the measurement model is what we say is a confirmatory factor analysis, right. So, apart if you can go understand the word, so there are exploratory factor analysis and the other was confirmatory factor analysis. Okay. So, this part confirmatory factor analysis part is the measurement model. Okay. So, this confirmatory factor analysis is used as a measure to reduce the measurement error of a study, right. That means what? When you have measured certain things and that those things could have been measured and the researcher the respondent might not have taken serious interest or something, and something has happened, right. So, in a CFA case what happens is, here it tries to build a latent construct, basically a latent construct which is made up of certain variables, right. So, these variables together will represent the construct, let us say. Okay. So, this construct in the measurement models, we say what we do is we basically create a covariance matrix or a covariance structure, right. In a covariance structure, if you remember, we have also discussed that it is like a correlation structure only, but a correlation is a special case of covariance, right. So, here we try to see whether the model there is a covariance relationship between the constructs, right. And finally, what we do is we try to see in the CFA case we first check the construct and for its reliability and validity. Okay. So, you checked for validity through the construct we say the construct validity. So, to do the construct validity we use certain ways, for example, we convergent validity, discriminant validity, right, and nomological validity, right. So, convergent validity, I am sure you are very clear with, because in convergent validity only thing you want to see is that whether the items are converging towards the main construct. Okay. So, if the items are sufficiently having a larger value, right, the correlation between the item and the construct is high, or inter item correlation you can say is high, then we say this is a high reliability. So, that helps us also to understand the convergent validity, there is a convergence, but discriminant validity occurs when we try to measure whether two constructs are sufficiently separate from each other. Okay. So, construct A and B should be sufficiently different from each other. So, to do that what we use is the average variance extraction, right, value, and compare it with the let us say the correlation, right, correlation. And we always say that the average variance extraction should be higher than the squared correlation value, right. The squared correlation value whatever comes, it should be the AVE should be higher than that, then that shows a discriminant validity. Okay. But let us say now comes a case, once we have done the measurement, we have it is a measurement model. So, we have measured and we found that the construct is justifying and it is explaining what it should explain, okay. It is doing its job with the help of the model fit indices we have said. Now, the model fit indices are basically we use the chi-square by degree of freedom, which we always say should be as less as possible. So, in between let us say anything less than 3 is good, we say, right. We have taken a magic value of 3, right. But some people some researchers also say anything up to 5 is still good, right. So, what does it mean? The chi-square by degree of freedom basically talks about that it compares against a baseline model. That means there is a model and it compares what it is saying is the observed and the expected model, and the expected model, the difference should not be very high, right. So, when we are measuring the chi-square by degree of freedom and if it is sufficiently 3 is around less than 3, then we say that the model is a fit model, okay. There are other fit indices also, for example, the goodness of fit in GFI, IFI incremental fit index, right, and you have CFI right, confirmatory fit indices. So, these are some of the absolute fit indices which are used and we have a magical number we say of 0.9. So, 0.9. So, if it is if these values are above 0.9 and you might not take all the values, you might take only one of from the absolute fit indices and one from the incremental fit indices, right. So, if you take these values and see that this is above 0.9, then along with the chi-square by degree of freedom and these we say that the model is a fit model, right. And we also find something called the RMSEA. This is also an important thing which takes the root mean square error basically and the RMR, right. So, this is the residual, the root mean of the residuals, right. So, the residuals are the unexplained. So, unexplained part, the residual, the square of the unexplained, right, basically it takes, right, and the RMSEA. Now, if these two values are sufficiently good, below 0.8 we say for RMSEA is 0.08, 8%, below 8%, less than 8%, then it is a fit model. So, after doing all this, we have understood that there is the measurement model has been used to check for the construct's validity and reliability. But now comes a situation where we have to check whether there is a relationship between the constructs or not, or what kind of a relationship exists between the constructs, right. So, to do that we use the path analysis which is the path analysis, right. So, the path analysis basically is the structural part only, right. So, what is happening here, we are saying model construct A is affecting let us say construct B. This is a simple case like a regression only, but suppose now we are adding a third variable, let us say C, the third construct. Now, we are saying that if in this case it is becoming more than a simple multiple regression. In a multiple regression case you had this was the let us say dependent variable, this is the independent variable, but now in this case this has changed its characteristic and it has become a new independent variable and this has become the final dependent variable. So, in such a condition, which is actually what it is happening in real life, right. So, one becomes the father of a house is the family is dependent on the father, but the father is maybe dependent on his on the office or the his office ambience, office the climate, or his let us say the boss, right, or wherever he is working. So, if he is tomorrow let us say suspended from his job, then his family will get affected, or if he is given a promotion, then his family will be positively affected. So, let us say if I take it, although it is a very crude way of understanding, this is the boss or the employer, let us say the boss is a bad word, the employer, the father and the let us say the children. So, the children are dependent on the father is dependent on the employer, right. So, this is a case where we want to establish such kind of relationships. To do that, we use structural equation modeling. So, it is a process for testing a structural theory, right. A structural theory is a conceptual representation of the hypothesized relationships between the constructs. Now, this relationship that we have built, they are hypothesized relationships, we are yet to prove it, right. So, how do we prove it? Now, we will see. So, how do we prove it? So, after the mechanism becomes like exactly like a multiple regression only, okay. So, it can be expressed in terms of a structural model that represents the theory with a set of structural equations. So, everywhere there is a new it is a case like a simultaneous equation, right. So, you are creating different equations, right, from here to here, here to here. So, these equations that you are building, now you are testing them with a the structural model represents the theory with a set of structural equations and is usually depicted with a visual diagram. The visual diagram is this, okay. So, what are we focusing here? We are focusing on the overall and the relative model fit, right, and the size, direction and significance of the structural parameter estimates. Now, the estimates, the word estimates, if you these are some simple the regression estimates, the regression coefficients, right. Now, with the help of the estimates, we can say whether a hypothesis is to be accepted or rejected. The estimates will help us to say whether a hypothesis is to be accepted or rejected. Now, this is a structural model, but one thing before we get into the structural model, please remember that the structural model, the relationship that you have built, in this case was the C, right, it should always emerge from an existing theory. It is not that we liked something like the A is affecting C, we will say or C is getting affected by A. Now, that is something like out of basis, out of reason, right. So, just pulling an arrow to make some to just prove your point or prove somebody's point is not the right thing to do. Your model should be built upon very clear structure theoretical premise, okay. So, there are two constructs here, customer share and customer commitment. Customer share has got 4 variables, customer commitment has again got 4 variables, right. This lambda, if you see the lambda, these are the factor loadings, as you saw factor loadings in factor analysis, exploratory factor analysis. Similarly, these are also the factor loadings, okay. So, the structural theory hypothesizes that customer commitment results from customer share, the customer share, right. So, the arrow moves from, that means the arrow is moving from customer share to customer commitments, because customer commitment is a dependent variable, right. So, structural equation modeling, there are 6 stages. The 1, 2, 3, 4 here, if you see, defining the construct, developing the overall measurement model, designing the study to produce empirical results, assessing the measurement model validity is a part of the measurement model of the CFA, right. The 5 and 6, specifying the structural model and then the assessing the structural model validity is the 5 and 6 are the part of the structural equation, right. So, the structural model. So, remember when you have let us say after you have done the measurement model, right. So, whatever your the fitness indices have been generated, right, the structural model should be better than the measurement model. The structural model should always be better or have a richer value or higher value than the measurement model. If it is not happening, then there is not much of a significant improvement, right. So, we need to understand that the measurement model was only measuring the constructs, but structural model you are putting in some relationships, right. So, the structural model has to be more powerful and robust than the measurement model, okay. Okay. So, how do you convert a measurement model into a structural model? So, now you see the A, this is a measurement model. So, A, B, C, D are these are all there is a covariance relationships, right. So, there is a double headed arrow to from one construct to the other, right. So, this double headed arrow is basically nothing but still talks about the covariance relationship, right. But here if you look at the structural model, it is very clear in saying that A and B affect C, C then affects D. Okay. Now, these things that you see that for example, this symbols, right, these are called the error terms. So, if you these are the sometimes we use it simple, we use E1, E2, right, kind of error terms. Now, what is the error terms? Time and again I have been explaining, the error terms are nothing but the unexplained part, right. So, in this case there are 4 items or variables related with each latent construct, and 4, 4, 4, 4, and there are 2 error terms here, right, because every dependent variable will have a error term, right. The obviously the independent variables do not have an error term, right. So, why then this is also an independent variable, then why it is having an error term? Now, because it is also an independent variable for these 2, okay. So, that is why. Now, I am not getting into the recursive and non-recursive model, but just to, if you want to understand, because a recursive model is something where there is a if you look back, this is a non-recursive model, and the recursive model is the only difference is that when there is a one sided when the arrow moves from one direction towards one direction only, we say it is a recursive model. On the other hand, when there is a dyadic relationship or a double the path is moving both sides, right. So, in that case this is called a non-recursive SEM model, right. So, now let us look at this case. This is a HBAT from the book of Tatham and Black, Hare and Anderson. So, from there we have brought. So, these are some of the constructs and their relationships. So, these are the endogenous variable, this is the endogenous variable, these 2 are the exogenous variables. Exogenous means independent and endogenous means the dependent, okay. Now, hypothesis is, there are several hypotheses if you can see. The H1 is saying EP. Now, what is EP if you want to see? Then I think it will be here. EP is environmental perception, AC is attitude towards co-workers, SI is staying intention, OC is organizational commitment, and JS is job satisfaction, okay. So, environmental and what was this co-workers, I think attitude towards co-workers are affecting the job satisfaction and the organizational climate, finally affecting the staying intention. So, the hypothesis is that environmental affects JS, job satisfaction, environmental also positively affects OC, AC affects JS, AC affects OC, right, and then JS affects SI and OC affects SI. So, 1, 2, 2 here 4, 5, 6, 7, right, and JC and OC there must be 1. So, if you see job satisfaction leads to organizational commitment, this is one more, right, kind of a relationship. So, this is a very complex relationship, right. So, I am not getting into back into CFA now. So, yes. So, so let us look at this, right. So, if you are having such a condition, now you have established a relationship. Now, what should you do after you have got the structural model intact? Then what you need to do is you need to find out the model fit, right. So, as you did in the measurement model, similarly you need to find the model fit for this case also, and I said that the model fit should be better than the measurement model, right. So, once you have the measurement model, then what you do is after you check for the model fit, suppose it is the model is fit, then you go to the next thing, that is to check for the fitness indices. Now, in the fitness indices also you have, suppose you have checked and they are all coming 0.9 and above. So, that means the model is now clear, it is a fit model, right, there is no problem with it. But in case there is a problem of, let us say there is a poor model fitness is showing, then Amos has a facility to improve the Amos is the software which you use for Lizerl and Amos being a very popular software. There is, to improve the model, you can do one thing, you can use the modification indices. So, modification indices are one such value which is used to improve the model fit. Now, if you have the modification indices, then this indices what it does is basically tries to find out which are the error terms which have got lot of there is a which there is a lot of unexplained part into it. So, that those two errors are combined, so that the unnecessary unexplained part will get reduced and the model will improve better, right. So, okay. So, once you have done this, then what happens is, let us go back to the hypothesis. Now, what you do is you need to go for the estimates, right, the estimates. So, the estimates will SEM in AMOS at least helps you in providing these estimates. These estimates, as I told you, are nothing but the coefficients, regression coefficients for each value. Now, it will also give you with it the estimates as well as its significance, right. So, when it gives you the significance, right, from the significance, if suppose something is significant, right, the significance is shown in triple star or double star, look depending on 0.01 or 0.05 or 0.001, right, kind of a significance level. So, when you are going through that estimates, you need to check that relationship. Suppose JS EP to JS. Now, if that relationship is it will give you an significant or non-significant relationship, it will explain that. So, if your significant relationship is significant, then we say that yes, JS is really getting affected by EP and it is not due to chance that it has happened only this time, right. Similarly, suppose out of it, suppose you found ki only one of them, let us say JS and OC, JS job satisfaction leading to organizational climate, this is not coming significant. That means what? In this model, we have theoretically assumed that job satisfaction also leads to organizational climate and thus it affects staying intention, right. So, this is not coming true. That means this hypothesis is a false hypothesis. We cannot say that JS actually affects OC and then that affects SI, right. So, this is one thing that that you are given, right. So, after the end you will get all the estimates and with their significant significance values, and through that you can accept or reject your hypothesis, right. So, in this case there are 7 hypotheses and we said tentatively, let us say only one of the hypothesis is not accepted or it is rejected, let us say. So, it is rejected. So, we say in this study there are 7 hypotheses, out of which the first 6 hypotheses were significant and it showed a positive effect as the relationship, you have to explain through the relationship, but only one of them did not show a significant relationship. That means it shows that there is no effect, okay. So, when you do this, you need to understand that there is something also. For example, let us say there are 2 constructs, let us say 2 constructs, this is a third construct, let us say this is a fourth construct, let us say, right. Now, there is something we need to understand A, B, C, D for example, okay. So, now if you see in this case A is affecting D also through C, okay. B is also affecting D through C and as well as directly in this case if you look at it, right. So, B has a direct effect also and B has an indirect effect also. So, let us say these two are the factor loadings are 0.5 and 0.5, right, and this is let us say 0.4, right, and this is let us say 0.3, these are the factor loadings I am giving. Now, what will you understand from here? There are 2 types of effects, one called the direct effect and the other called the indirect effect. Now, in this case you have to understand that the indirect effect from A to D through C, an indirect effect means when the variable passes through a intervening variable, that means a mediating variable, intervening, you can understand a mediating variable, right, which is behaving like a mediator in between, right. So, 0.5 into 0.4 is equal to 0.2. So, the indirect effect is 0.2 for A to D, and similarly from B to D it is also let us say this could have been 0.4 also. So, 0.4 into let us say 0.4, so 0.16 let us say. So, this is from, and what is the direct effect from B to D? Now 0.3. So, here we say that the direct effect from B to D is higher than the indirect effect, and in this case what is the total indirect effect? The total indirect effect is 0.2 plus 0.16. Okay. So, many a times it happens, it is of interest to a researcher to know ki whether if a mediating variable comes into the picture, whether it is advantageous or it is not required. Sometimes it is like a catalyst, you have to understand, like in a catalyst the presence of a catalyst will change the reaction, right. So, direct effect might be, let us say the direct effect might be significant, might not be significant, right. So, if it is whatever and the value could be less or more whatever, but suppose if it goes through a mediating effect, the mediator, then suppose we see that it is significantly improving, the value is improving, then we say that there is a presence of a mediation effect, right. So, let us see what is this mediation, as you can see here, right. So, K goes through to E through M being the mediator, right. So, M mediates the relationship between K and E if the direct effect of K on E is diminished when M is also a predictor of E. So, we will, if suppose you have a direct effect, nobody wants a mediator until unless the direct effect is not so good, right. So, if your mediator only adds to the explanation or adds to the strength of the relationship, then only the mediator is a justification, otherwise there is no justification for mediation. Okay. Now, adding direct effects, so how do you check for mediation? Although this will not explain much, I will do it directly here. Let us say there are two types of mediation. So, one is a partial mediation and we say the other is a full mediation. That means, we will say the mediator has a partial effect or the mediator has a full effect. Now, what is this full and the partial? Let us say A, M, let us say B. Okay. So, this is something like this. So, when A has a significant effect on the mediator and M has a significant effect on the dependent variable, right, then, and suppose A and B also, this is a Baron and Keynes method, is a very, although some people say it is a very old method, but still it is a very basic method and it is a very clear method. Suppose the presence of a mediator and the absence of a mediator, if there is a presence of the mediator and the absence of a mediator, if the significance level changes, let us say the direct effect, let us say when you bring in a mediator, let us say the relationship becomes strongly significant, right, and the direct effect shows not so strong, then we say it is a case of a full mediation, right. That means, when suppose A to B is now was earlier is significant, now also is not significant, let us say, and through this is becoming significant, right, then we say there is a full mediation. Suppose both are significant, but this has got a lesser value than this, then we will say it is a partial mediation, right. So, these are the ways of justifying or identifying. Okay, this is written. So, mediation involves the comparison of a direct effect between the two constructs while also including an indirect effect through the third construct. Full mediation is found when the direct effect becomes non-significant, as I said. So, when it is non-significant and in the presence of the indirect effect, whereas full mediation is when it is non-significant, whereas partial mediation occurs when the direct effect is reduced but still significant. That means what? If I go directly, also I will get some money, for example, but if I go through somebody, I will get more money, that is a partial mediation. But suppose if I go directly, I will get no money, but if I go through somebody, I will get full money, then it is a full mediation, as good as that, right, you have to understand. So, well, these are some of the things. Okay, there is one more important thing. This is called after a mediation we say there is something called a moderation also. Now, what is a moderator? A moderator, there is always a something like there are some things which are used as a moderator. Now, some things automatically moderate the relationship. Okay. Now, what is the moderating the relationship? Now, for example, many cases generally what is used is gender we say is a moderating variable. Now, what do you mean by moderating? That means whatever the relationship you studied in this case, for example, or the 7 hypotheses, that might behave differently for male and differently for female. Okay. So, if you exercise the same thing for male and you exercise the same relationships and test the relationships for female, that means it is different. So, if you take only gender as one, that means there is you are not able to get into deep and you are not explaining it well. So, if you do a moderation test, then we can easily explain that whether gender also is gender is moderating the relationship between, let us say I am saying here I am putting in a moderator. Okay, moderator. Now, I am saying the relationship between A and B is moderated, there is a mediator also, but there is a mediating and moderating effect, both are there, right. So, there is the moderator is affecting the relationship, right, is affecting the relationship. So, how do you check for moderation? It is very simple, there is nothing very complicated. In case you have continuous variables also, you can use a moderator, because generally there is a confusion between researchers that moderator should be a categorical variable or not, right. If you have a continuous variable also, what you can do is you can use some logic and create some categories in it. For example, let us say income from 0 to let us say 0 to 10 lakhs is let us say 1, 10 to let us say 20 lakhs is 2, 20 to let us say above is 3. Now, by doing this, what I have done is I have categorized the variables, right. So, moderation can be tested with multi-group SEM, right. So, what you do is simple in a moderation test, you first define the groups and then you run it by taking each part of the each group individually. So, by taking it will have two values will generate. One, suppose in this case all the 7 hypotheses, that 7 JS and all these things. So, if you have for male you will have a particular the 7 hypotheses, the relationships, right, 7 hypotheses. Similarly, for female also you will get it, right. Now, then how do you know that moderator, what should you do? To look at the effect of the moderation, the best is to see is there any variable or any relationship that is significant in male and maybe not significant in female, or vice versa. Only pick up those relationships which are significant in both the cases. The ones which are not significant in either one of them, they are items for deletion. Okay. So, by doing this, basically what you are doing is you are using a moderation technique. Yeah, this is another way also which I was saying. The moderating variable can be collapsed into groups, which I explained, or cluster analysis also can be used to identify the groups, right. That is also by the hierarchical clustering you can identify the groups also, that is the one method. So, whatever it is, so you have understood that structural model helps in identifying the relationships, how they go, and if there is any mediating effect we can check, and finally if there is a moderator, how is the moderator affecting the relationship, that also can be checked, right. So, this is all we have for SEM now. Thank you.